This is my fourth video lesson on Unit 8. In this lesson, we'll be describing vapor pressure and using Table H. Go to page 17 in the class packet. We will be discussing why water has different boiling points. An open glass of water is left standing around, or droplets of water will eventually evaporate even while being heated. Why does this happen? Liquids will evaporate eventually because occasionally the liquid particles with enough energy will have enough force to overcome the intramolecular forces between the liquid particles. That is why water will eventually evaporate. Learning target. At the end of the lesson, I'll be able to describe vapor pressure of substances using Table H in the reference table. Homework B number 4 will be a Junipod based on this lesson. There will be a quiz Junipod, and the exam will be on Unit 7 and Unit 8. Vapor pressure is the pressure exerted by a gas released from a liquid or solid in a closed system. In this container, we have particles in the liquid state becoming a gas. The gas particles will exert a pressure. The arrows represent the vapor pressure. Vapor pressure can be measured in a closed system. That way the gas molecules will not escape. Check of understanding number 1. If a substance has high vapor pressure, is it easier or harder to evaporate? It will be easier to evaporate because the substance is turning into a gas exerting pressure. Volatile means how easy something evaporates. Here are some examples of substances that are volatile. Non-volatile means it does not readily evaporate. There are two factors that can affect vapor pressure: temperature and intramolecular forces. We will discuss how each of them affect vapor pressure. Just to review, what was the relationship between pressure and temperature of a gas? It was a direct relationship. Increasing the temperature increases the pressure. Therefore, temperature and vapor pressure have a direct relationship. If you increase the temperature, the vapor pressure will increase because the gas particles are moving faster, which then exerts more pressure. Learning check number 3. Which sample of water has the lowest vapor pressure? Pause the video and resume once completed. So the one with the lowest vapor pressure will have the lowest temperature. That will be choice 4. Learning check number 2. As water in a sealed container is cooled from 20 degrees Celsius to 10 degrees Celsius, its vapor pressure does what? Pause the video and resume once completed. Since the temperature decreased, the vapor pressure will also decrease. For the relationship between vapor pressure and intramolecular forces, let's look at this example. A and B are two liquids in a closed container STP. Which substance has a higher vapor pressure? By looking at the diagram, it will be substance B because it has more gas molecules vaporizing. Question 2. Which do you expect to have a stronger intramolecular force, and why? That will be substance A because it evaporates more slowly than substance B. That's because A has more particles attracted to one another than B, so A has stronger intramolecular forces. So what's the relationship between intramolecular force and vapor pressure? Is an indirect relationship. The stronger the intramolecular force means lower the vapor pressure. Why is that? Because particles with a stronger intramolecular force are more attracted to one another. Therefore, it will be harder to vaporize. So we'll have a lower vapor pressure. Sublimation is when a substance goes from a solid state to a gas state. Typically, substances that sublime in room temperature have high vapor pressure and low intramolecular forces. Here are some examples of sublimation. Here's iodine, and here's CO2. Boiling point, which is the temperature in which a liquid becomes a gas, can also be defined as the temperature at which the vapor pressure is equal to the atmospheric pressure. When the vapor pressure is equal to the atmospheric pressure, your liquid will boil. So there's two forces acting on the liquid: the vapor pressure, which is pushing up, and the atmospheric pressure, which is the air pressure pushing down. When these two forces are equal, your liquid will boil. Take a moment to watch a TED video about the air pressure. The link to the video will be in the descriptions. Once you watch the video, resume this one. There are two forces acting on the liquid. The vapor pressure is pushing up, and the atmospheric pressure is pushing down. Boiling only occurs when both forces are equivalent. Normally, the air pressure will be greater than the vapor pressure. That's why liquids do not spontaneously boil at STP. So how do we make a substance boil? We can either increase the vapor pressure or lower the air pressure. We can increase the vapor pressure by increasing the temperature. This is what happens when we boil water in the kitchen. We turn on the heat and the water vapor will start increasing. Once the vapor pressure is equal to the air pressure, the water will boil. Here's a GEV of boiling water by increasing the temperature. By increasing the temperature, you'll be increasing the vapor pressure until it's equal to the air pressure. You can also boil water by lowering the atmospheric pressure. Here we're using a vacuum to remove the air molecules inside this container. By doing that, the air pressure will decrease until it is equal to the vapor pressure. Once it's equal, water will boil. So as you can see here, water is boiling at room temperature. That is why water will boil at a lower temperature at higher altitude than at lower altitudes. Now we're going to go over how to read Table H on the reference table. Table H is the vapor pressure of four liquids, propanol, ethanol, water, and ethanoic acid. On the y-axis is the vapor pressure measured in kilopascal. Each interval goes up by 10. So this will be 0, 10, 20, 30, 40, 50. On the x-axis is temperature, which is measured in Celsius. Each interval goes up by 5. This is 50, 55, 60, 65, 70, 75. The dashed line in the middle of table H is standard pressure, 101.3 kilopascal. This is at sea level. If it's above standard pressure, then it is below sea level. If it's below standard pressure, it is above sea level. I circle a couple of points on the propanol curve. As you can see, as you go up, the pressure will increase. As you go down, the pressure will decrease. Air pressure is lower at high altitudes. Why is that? Because at high altitudes, there's less air molecules pushing down versus at lower altitudes. Learning check number 3. At which temperature is the vapor pressure of ethanol equal to the vapor pressure of propanol at 35 degrees Celsius? Pause the video and resume once completed. The first step is to figure out the vapor pressure of propanol at 35 degrees Celsius. At 35 degrees Celsius, propanol has a vapor pressure of 48 kilopascal. At 48 kilopascal, ethanol has a temperature of 60 degrees Celsius. The answer is choice 2. Learning check number 4. Which compound has the lowest vapor pressure at 50 degrees Celsius? Pause the video and resume as completed. At 50 degrees Celsius, I'm going to circle the vapor pressure of each substance. As you can see, ethanoic acid has the lowest vapor pressure. The answer is choice 1. The dashed line represents standard pressure. We can use it to figure out the standard boiling point of each of the substance. When each curve intersects the dashed line, we can look up the temperatures. So propanol boils at 56 degrees Celsius, ethanol boils at 79 degrees Celsius, water boils at 100 degrees Celsius, ethanoic acid boils at 117 degrees Celsius at standard pressure. Below sea level, you're expecting a higher atmospheric pressure. Above sea level, there is a lower atmospheric pressure. Each substance will boil at a higher temperature when the atmospheric pressure is greater than the standard pressure, which is at below sea level, and they will also boil at a lower temperature when the atmospheric pressure is less than the standard pressure, which is above sea level. For example, water boils at 100 degrees Celsius at standard pressure. If you increase the atmospheric pressure in below sea level, water boils at a higher temperature because the atmospheric pressure is greater than the standard pressure. At above sea level, water will boil at a lower temperature because the atmospheric pressure is less than the standard pressure. This is true for each substance. Why do substances have different boiling points at standard pressure? This has to do with the intramolecular forces. So let's look at the substances. As you can see, propanol is the only one that does not have a hydrogen bond. It has a dipole-dipole interaction. Therefore, propanol has the weakest intramolecular force. Just to review, the relationship between intramolecular force and boiling point is a direct one. The stronger the intramolecular force, the higher the boiling point. Therefore, propanol should have the lowest boiling point. Table H has four curves. The curve closest to the left will have the weakest intramolecular force because it will have the lowest boiling point. The curve closest to the right will have the strongest intramolecular force because it has the highest boiling point. Therefore, ethanoic acid will have the strongest intramolecular force, then water, then ethanol, and then propanol. Which substance is least volatile? Most volatile. This is dependent on the intramolecular forces. The stronger the intramolecular force, the least volatile it is. So that will be ethanoic acid. The most volatile will have the least intramolecular force. That will be propanol. As intramolecular forces increases, boiling point increases because more energy is needed to overcome those intramolecular forces. As intramolecular forces increases, vapor pressure decreases because stronger intramolecular forces makes it more difficult for particles to move apart. Learning check number 5. As the atmospheric pressure decreases, the temperature at which water will boil in an open container does what? Pause the video and resume once completed. The answer is choice 1. You can check this using table H. Now try to do these practice problems on your own. These practice problems are based off table H. Pause the video and resume once you complete them. Here are the answers. This concludes the video lesson. Remember to do the Juniper homework and quiz.